All right, so I killed this this board. I thought it was just the chip that I killed. So this is the old chip. This is the new chip. I ordered some off of eBay for £2. So I did a video on this, an hour-long video detailing everything as to how this board works. It's an amazing board, really, and I learned a lot doing it. But I killed this chip by reversing the voltage, and the magic smoke got released. So this chip's obviously unusable. But then what I saw was spiking over on my power supply. I was getting 4 amps going through the circuit. So let's just see what happens now. I'll turn on my power supply. It's a bit awkward to try and get it to work. So there you go. You can see that it just rings blue. So, and actually what I had previously when I first tried it, it just went red only. So I'm not sure what's happening there. I'm assuming we've got some sort of fault. So, I mean, we definitely have some sort of a fault, right? So the obvious thing would be to just go out and buy maybe more 555 timers and see if that fixes it. I may have some in some of the other kits that I got. I think I might do so. I'll check those other kits. But what I'm thinking of maybe doing is probing around here with a multimeter to see what's off. So I might give that a go. Alright, so there's not that many things that it could be, right? It's probably going to be either the transistors. The resistors seem like they're fine, but I could test them, you know, sure. I'm guessing since only one side's turning on, but like I said, this side did turn on previously, so I don't know, but I would assume that it's going to be the transistors, possibly the diodes, but again, I doubt it, because they have, obviously, I didn't put, even I reverse bias these, I didn't put over 1000 volts, so they have 1000 volt protection, so they should be fine. So transistors or any 555 timer. Now, okay, so I've got my multimeter here, so let's put it onto the diode testing. Alright, select here, diode. Alright, so these pins, these three and these three are our transistors. So if I put my positive lead onto the base and then now touch, I believe this is the this is the collector, so 0.7, so that seems about right, diode right, and then again this side 0.7, so that tells me that this diode's fine. So same again here, so this is on the diode testing function, right? So now here 0.7 and again here 0.7. Alright, so it tells me my diodes are fine. Okay, now another thing I want to do is if we go to the short tester one to test for shorts, so when you connect it you get a beep, right? Okay, now I'm looking at this NE55 timer and I'm guessing that this is where the problem is. So let's just, if I maybe touch one pin, even that doesn't look the best. Can you see that? Oh, there's some black stuff there. I didn't notice that before, so the others kind of have it as well. Alright, anyways, so let's just, you hear the beep, right? It's quite finicky to do this. I don't know how people do it on SMD components. You must need really good multimeter probes, because this is difficult for me. Alright, hold. Alright, so I'm holding that one on that pin. So if I just start touching the other pins, so none of those are shorted. Then I've got to do the same. Okay. Is that shorted or? This is hard, man. I think best thing is if I just take the 555 timer out of the circuit and then do it like that. Alright. Alright. Okay. Okay. So they seem to be fine to me. Alright, so I prodded away with my multimeter and the diodes are all fine. The resistors are all fine, standard values. Now with the 555 timer, I realized that a better way to probe it would be to, let's just put this back to, here you go, would be to probe it on this end, and I can actually see the traces on the PCB where, for example, so here, you can see that this trace along here, all of here, goes to this pin. So even though it looks like they're shorted, that's obviously intentional by the PCB. You can see that trace going around here to there. So these aren't shorted, and obviously they shouldn't be. So I can see which ones, these two pins should be shorted, and they are. You can see that these ones shouldn't be. And then these two here, okay. So now here, nope, okay. So in terms of shorting, the 555 timer seems fine. Best thing to do is probably just replace the 555 timer anyways, and then see where we go from there. But alright, so I tested for shorts everywhere and I couldn't really find anything, but thankfully I've got this little speaker. I think it's a sound speaker kit, I don't know what it is, but it comes with a 555 timer there. So I'm going to take that out and we're going to try it by replacing this, and hopefully that just works. No pins bent, thankfully. Straight in, nice. Okay, so let's make sure we connect them the right way around now. This connector is rubbish. Alright, so we've got 11.8 volts ready. Boom. Whoa, that's better. Alright. It's not a consistent connection, but you can see it's working. I think it's working now. Okay. The red seems to be a bit dim, but no, I think it's working. Let's try to change the frequency. So this is the slowest. There we go. Alright, it's working again, people. Yes! Perfect. So it appears by reversing the polarity, it killed both the chips. So I'm going to order another 555 timer now then to put in this that I took this out of. Okay, what next? What should we do next? So there's a fair few things that I'd like to do with this circuit. One of them being cutting off the LEDs on both sides and then having them basically, so you've got this main board here, and then so for example, like maybe I could wrap that in some waterproof something, tape or I don't know, and then have the red LED separate, blue LED separate, or maybe have them together but away from the board, and see if I can get that working. I'd also like to change the inputs on this. I just don't like this string. I'd rather have those DC inputs like I've got, for example, in this kit here. See these little pins here? I'd rather have something like that. So maybe I could do that. But first things first, I've already blown up both these ICs once. I don't want to blow them up again. So let's add some reverse voltage protection to this ground, so that way when if I accidentally reverse the polarity again, at least I'm not going to go and kill the chips. So the way that I'm going to do that is using a diode. Let me grab one. So I'm guessing most of you will know what a diode is, but I'll show you anyway. So you've got, this is a standard diode, and then these ones that they're using here are Zener diodes. I'm not sure why they're using Zener diodes. Yeah, I don't know. But anyways, this diode here is a 1N4007, 1N4007, and you can't really see it on its thing. But basically it has a reverse voltage breakdown of 1000 volts. So if I stick it this way into the ground, right? Then if I was to come along now, let's say I didn't have this blue wire anymore. Get rid of that. And then so I've got my input and I've got my ground. If I put the input voltage here and ground here, it will try to send 12 volts this way, but this diode here acts as an open circuit and it won't allow the 12 volts to come, or it won't allow any current, I should say, to go that way, right? However, if I put the 12 volts in this way, when the current comes from this way, the opposite way, right, then the current flows freely. I'm knocking it over like an idiot. The current flows freely that way. So let me show you an example of how it works on a breadboard. Alright, so here I've got 2 diodes, and technically I've got 4 diodes, but let's not get confusing. You got 2 LEDs, 2 diodes, and then they're literally just connected to VCC, which is here, and this is my power supply, and then the LEDs are grounded over here. So we've got power supply. So you can see here, power supply is supplying 3.4 volts. And so from here, you got 3.4 volts at the input here, which comes to this pin and this pin, or this jumper wire, comes across, meets these diodes. In one of them, the current flows through the diode and goes through to the LED. The other one, the diode is blocking the current, and hence no current gets through to this LED, and so this LED doesn't turn on. So let's have a closer look. So you can see there that this diode in this direction is forward bias. You can tell that from the silver line, which is there. So there you can see that current flows fine through it, but this silver line is on this direction of VCC, hence it's blocking current. And so we want to use this configuration here such that at our input terminal for the ground, then we're going to have the silver facing outwards, and this bit connected into the actual circuit. So we're going to configure our diode in this configuration. We don't want it obviously in this configuration. So the obvious thing to me appears that if I just desolder this wire and put a diode in there and have it flush against the board, then that should just serve as, you know, that should just work basically. So that's what I think I'm going to do. Alright, so I just need now this silver wire to be on the outside. So if I just put this through here like this, so like that, right? Technically I could just use this as the ground and just connect the ground onto the end of this diode like that. Alright, let's solder down this diode. We'll solder this down like this, like that, right? And then we'll go from there. Alright, so that's done. So you can see there the diode's just down flush like that, or standing up. So now, you know, that's quite an easy connection to get with the ground. So I want to fix this ground thing. I think I'm just going to stick one of those small, like you saw here, these jumper cables. Just going to stick one of them onto there because this cable is just ridiculously flimsy. So let's just quickly desolder that. There you go. And then we'll get a jumper cable. Here we go, so simple with the red one. Hopefully that way I won't mix up VCC. Alright, let's go it in. There we go. Right, just need to make sure there's enough solder on there. Let's add some. Quite a little blob, but I think that'll do. Alright, and then let's just cut this off. Alright, so now hopefully that's a much better ground and input. So let's test it out. I mean, I'm excited for this. I've never done anything like this before. So yeah, this is I may be about to kill my chip, well, both of them again, which is funny. So we're first going to test it out forward biased, just normal, right? So positive to positive, and negative to negative. Okay, so let's turn it on. So here we got 3.4 volts, so all good. Let's go up to 12 volts. Okay, well, so 8 volts, the red LEDs go on. 9 volts. There we go, we got 10 volts. Cool. So 12 volts, and we're fully working as normal. Good to see, so I didn't mess anything up there. Cool. Alright, so we're still working. So now, moment of truth, people. Let's this is gonna go bad. Oh man, please don't let any magic smoke come out. I mean, it's not possible, right? It's not possible. Literally, it's not possible for 12 volts to go through that diode. It's just not. So, okay, so here we go. Negative to there. Oh dear. I mean, is there anything else that can happen? Like, I'm just, because I haven't done this before, I'm thinking now, if I connect this, am I going to get any sparks? I don't think so. Oh, bloody hell, man. Alright, ready? Steady. Way. Nothing. Nothing. Sweet nothing. Look at that, people. We did it. We created some very simple reverse polarity protection with just using one diode. Nice. Alright, now I suppose the ultimate test now is to then connect it correctly again and see if it works. Boom. Uh-oh. Why were they doing it at the same time? Okay. Yes. We did it, people. Well done. I mean, well done to me, I suppose, but well done for you. Well done to you as well for, I don't know, supporting me. I'm happy with this. Brilliant. That's absolutely fantastic. And the good thing is that this connector here, it's obviously insulated with the, so there's no way that they're going to touch as well. There's no shorting between them. I'm very happy with that. Very, very happy with that. So we've got no chance of killing our chips now. One thing I would like to do is, let's turn this down to 9 volts, right? So at 9 volts, we're not able to get our blue LEDs to turn on. And that would be the perfect voltage, because at 9 volts, you can use a 9 volt battery. So how would we go about getting this to work off of 9 volts? Both the red and the blue. So looking at the schematic, the only things that I can think about are these resistors here, the R2 and R3 that are 10K, but those limit the current going to the base of the transistor. So that really shouldn't affect anything, actually. It doesn't make sense. So perhaps it's going to be these 100 ohm resistors here that are connecting to VCC. So we're talking about R4 and R5, the 100 ohm resistors, which I believe, okay, well, I know for sure actually, are these resistors here. So these resistors here are 100 ohms. Let me change this blue resistor to 10 ohms and see if we can get these to light up, because that would be ideal if we can get it to work at 9 volts. So yeah, let's do that. Let's desolder this. Alright, so this 100 ohm resistor has been desoldered now. So just going to stick in this 10 ohm resistor. Yeah. Okay, so that has been soldered in now with 2 giant blobs of solder. Alright, let's see if we can get it to work. Let's cut off these. I love it now. So now, look, I can connect this willy-nilly as I wish, easily to connect. And also, I don't need to worry about polarity, because if I get it wrong, oh well, it'll be fine. Okay. So now, well, now the blue isn't working. It's not getting hot, but Only the red is flashing. This is at 9.4 volts. So let me. Oops. What's popping there? Alright, let me crank up the voltage. So we'll go to 10.7 volts, and that works. 11.3 volts. So what's the lowest I can get it down to? So 10.6 volts. Yeah, it's basically off. Let's see if the... Okay, the resistor is not hot. So 10.3 volts. So I'm stuck here now because as far as I can see, this 10 ohm resistor affects the brightness. And now, okay, let's think about it. You know, this is where, you know, I'm at this end of my second year of electrical engineering, right? Surely I should be able to figure this out. You know, it shouldn't be too difficult, right? So looking at this schematic now, I need to get, let's just say this is our blue LEDs, okay? Just for simple sake. So these are our blue LEDs, this is our blue transistor, our blue diodes, our blue IC. Okay, well, these pins are our blue IC. The top pins are for the red IC, the red LEDs. Okay. How do I get more voltage to these diodes or these LEDs? I'm wondering if it's the opposite of what I've done. So going with the fact that these are blue LEDs, this 100 ohm resistor, I've now decreased it to 10 ohms. Okay, so that's more current flowing. Now thinking about Ohm's law, V is equal to IR. More current on. Okay, well, I don't know. I'm confused here. All right, let me jump onto simulation and try and see if I can simulate a way to get more voltage to the LEDs. Because even thinking about Ohm's law there, just confused. It's embarrassing, man. Proper embarrassing. Alright, so I played around a bit with my simulation, didn't really get anywhere. So what I'm thinking of doing now is just to short this out, basically. So let's just remove these this resistor again. And then what I'm going to do is, so once I've got this out, just going to put a jumper cable right across it. There we go. Alright, so for jumper cable, I'm just going to use another resistor. So I'm going to cut this off here, like that. And then now I'll just put... So what I'm hoping is that with no resistor there, then there's no voltage drop, and then maybe... Because if you think about it, right, I thought it would have worked with the 100 ohm resistor, the 10 ohm resistor, because with a larger resistance, you're going to get a larger voltage drop across it. And so I'd assume that no voltage drop across here means more voltage coming here. Besides, I'm thinking that it's just too many LEDs, maybe. I don't know. I'm really not sure. Anyways, let's just give this a go. So we'll just heat this bit up and push this through. Ah, you basket, burnt me. Alright, and then someone there. There we go. Okay. So now let's connect in our normal input. Hopefully we don't blow up any just turn my voltage down and turn power supply on. Alright, so power supply is on. We're at 7 volts right now. 8.3 volts, 8.5, 8.8, 9 volts. Sadly, nothing. We didn't manage to get to work with 9 volts. Let's keep going up. 9.9 volts, 10 volts. I don't think we're gonna have any success here. So this is on 11 volts. So it's only working at 11 volts. I'm not gonna be able to get it to work at 9 volts, sadly. I can't think of what else it could be, really. Okay, so I've put the 100 ohm resistor back in there now, and what I'm thinking is that, assuming that these two resistors are kind of like voltage dividers, and you've got equal current going from VCC to the red LEDs and the blue LEDs, even though I reduced this down to 0, it should have been the majority of the current going here. I'm thinking that maybe this 100 ohm resistor was still too low. I can't think of anything else that I'd be changing that would be affecting the voltage going to here. So I've got this 5k resistor here. I'm going to remove this 100 ohm resistor, go into the red LEDs, increase this to 5k, and just see, I don't know. I'm being hopeful here now. So I think I've tried my best here, and I'm unstuck now. So I've got a 5k resistor there, and on 10 volts now, you can see it flickering quite okay-ish on this side, less than normal, obviously, and that's to be expected. But here you can see it flickering a bit, but this is on 10 volts. So the idea that, if I crank it up to obviously, 12 volts, then what's funny is that even on 12 volts, actually, the red LEDs are barely blinking. Let's go above 12 volts. Yeah, so it's not working in its favor having this 5k resistor here. So I'm going to have to remove that to get it at least working normally again. But yeah, I don't see me being able to get it to work on 9 volts, sadly. Alright, so I think this video is going to go down as a semi-success, semi-failure. At least the good thing is I can't reverse the polarity now thanks to this lovely diode, which I'm happy with. I'm glad that I got it working again by obviously changing the ICs. It's sad that I can't figure out a way to make it work on 9 volts. The only thing I can think about is that there's too many LEDs, and possibly that's what's causing it, but I don't know that. I mean, let's just quickly, before we round up this video, let's just quickly test the voltage across our blue LEDs, because I know I should have done that probably before, but we'll do it now quickly. Okay, so I'm on 9 volts. So 1.8 to 2 volts I'm getting over here. So this doesn't make sense, right? So if I'm getting 1.8 to 2 volts, I think what needs to be done is some LEDs need to be removed. I'm not sure how else I can go about, because remember that these LEDs are connected to VCC. They've got nothing to do with these chips or anything, right? The ICs. They're connected directly to VCC, just, with a resistor between them. So these two resistors are the only things that, are between the 12 or the 9 volt supply and the LEDs. So for whatever reason, you should have 9 volts fully across all of these LEDs. 9 volts, 9 volts, 9 volts, 9 volts, 9 volts, because they're in parallel, right? So I'm sure you get that. Now, let's say if I had a voltage drop across each one, what would that be? I don't know. So as far as I can see, 9 volts should be enough to turn it on, but for whatever reason in the real world it only turns on like 10.5 volts. So I'm gonna take this video as a failure, and I hope that moving forward in the future I'll be able to figure out why this isn't working, because it's very frustrating to me. I'm a second-year electrical engineering student, and I don't see why after 2 years of studying electrical engineering I can't figure out how to get some blue LEDs to work on 9 volts. Very frustrating. I think the next thing to do might be to make just the blue half of this circuit on a breadboard and figure that out. But yeah. Alright guys, I'm defeated. This is a 1-0 to the cheap Chinese manufacturers that designed this silly thing that should work on 9 volts but doesn't. Alright, I shall see you guys in the next one, where hopefully I have some more success doing some other cool stuff with some circuits. Alright guys, take care.